In 2006, NASA launched a spacecraft called New Horizons. Its mission was to explore Pluto, which was known at that time as the ninth planet of the solar system. New Horizons traveled through space for 9 years before finally reaching Pluto. When it arrived, it became the first spacecraft in history to visit this distant world. Today, New Horizons has traveled more than 50 astronomical units away from Earth. That distance is over 7.5 billion kilometers. Even after all this time, scientists are still studying the data it sent back during its flyby of Pluto. New findings now suggest something surprising. Pluto seems to be far more active than scientists once thought. It is not the calm, frozen world many imagined. But how did astronomers reach this idea? What did they see in the images New Horizons sent home? And does this discovery mean there could be a chance for life on Pluto? Pluto is a cold, icy world. Its surface is covered with frozen nitrogen and carbon monoxide. Pluto was the first object ever discovered in the Kuiper Belt, a region of icy bodies beyond Neptune. For many years, Pluto was considered a planet, but in the 1990s, astronomers found several other large objects in the Kuiper Belt. Some were close to Pluto in size. This made scientists question whether Pluto should still be called a planet. In 2006, the International Astronomical Union decided to classify Pluto as a dwarf planet. Even though its status changed, it remained an important target for exploration. The images from New Horizons revealed something unexpected. The surface of Pluto shows many large, bumpy structures that look like volcanoes. They rise to different heights across the landscape. Surprisingly, these areas have almost no impact craters from asteroids or meteors. This is unusual because many surfaces in the solar system are covered with craters. After billions of years, there was also no sign of plate tectonics, the process responsible for forming mountains on Earth. All these clues together suggest that the surface in this region was formed by some kind of geologic disturbance. The most likely cause is volcanic activity, possibly a type of eruption involving icy material. Even though it may have happened up to 2 billion years ago, that is still considered recent when compared with the age of the solar system. Two huge features on Pluto have especially confused scientists. The first is a mountain called Reitman's. It is about 150 kilometers wide and rises nearly 5 kilometers above the surface. At its center is a deep depression almost 50 kilometers across. The second feature is called Picardman's. This one rises nearly 7 kilometers high and stretches about 225 kilometers across. What makes this even more surprising is that Pluto is only about 1/6 the size of Earth, yet the volume of this volcano is similar to Mauna Loa in Hawaii, which is one of the largest volcanoes on Earth. These giant volcano-like structures sit on the southwest edge of a large ice sheet called Sputnik Planitia. This area forms part of the bright, heart-shaped feature seen in many Pluto images. The ice sheet is an ancient impact basin about 1,000 kilometers wide. It has many folds and ridges that look like wrinkles across its smooth surface. In this region, scientists also found several round volcanic domes. Many of them appear to blend together into one larger dome. After studying the images recorded by New Horizons, researchers believe that the strange landscape on Pluto was shaped by many eruption sites, located close to one another. These eruptions were not like the hot volcanic activity on Earth. Instead, they were cryovolcanic eruptions, meaning they released icy material rather than molten rock. Scientists think these eruptions covered the entire region with thick layers of ice. A detailed study of the surface shows that the material in this area is mainly made of water ice. This is different from other younger parts of Pluto's surface, which are mostly covered with nitrogen or methane ice. The presence of water ice makes the idea of cryovolcanic activity even stronger, because water ice behaves differently under pressure and heat. But there is a problem. For volcanoes to be active, there must be a source of heat inside the planet. On Earth, volcanic activity is mostly powered by heat from radioactive decay inside the planet's interior. In some worlds, volcanic activity can also be caused by strong gravitational pulling from nearby massive objects. This constant pulling and stretching can create heat through friction. A good example is Io, one of Jupiter's moons, which is very volcanically active because of Jupiter's powerful gravity. However, neither of these explanations fits Pluto. Pluto does not have any neighbors with enough mass to create strong tidal forces. There is also not enough rocky material inside Pluto to generate enough heat through radioactive decay. Pluto's average surface temperature is extremely cold, around -240 degrees Celsius. Its crust is made of tough, rock like ice that cannot easily melt at such low temperatures. Since none of the usual heat sources apply, scientists are left with one big question. Where does the heat needed for cryovolcanic activity come from? The most reasonable explanation is that Pluto still holds some leftover heat from the time it first formed. This heat may be trapped deep below its surface. Many scientists think Pluto may have a subsurface ocean, a large body of liquid water hidden beneath its icy crust. This idea is not impossible. Other icy worlds in the solar system, such as Europa and Enceladus, are known to have underground oceans. In fact, Enceladus also shows clear signs of cryovolcanism. It sprays icy material into space, which helps replenish one of Saturn's rings. Even with these examples, the icy volcanic features on Pluto remain unique. Huge groups of ice volcanoes merging together, forming large fields that reshape the surface, have not been seen anywhere else in the solar system. This makes Pluto especially mysterious and exciting for scientists. It is important to remember that New Horizons flew past Pluto only once, and only observed it for a single day. Because of this, researchers do not know whether these ice volcanoes are still active or if they have gone quiet. It is possible that cryovolcanism continues on Pluto even now, but there is not enough information to prove it. If the volcanic activity is still happening today, that would strongly support the idea of a subsurface ocean. And if an ocean exists beneath the ice, there might also be the potential for life. Even though Pluto is far from the sun and extremely cold on the surface, a warm ocean hidden below could create the right conditions for simple forms of life to appear. This possibility is one of the most interesting outcomes of the New Horizons mission. Even after all these years, scientists are still studying the data collected during the flyby. The discoveries have changed the way we understand Pluto and other icy worlds. Pluto is not just a frozen dwarf planet. It may be active, complex, and full of secrets still waiting to be uncovered.